Welcome to Aerospace Propulsion lecture series. Myself, Dr.Praveen Kumar Balguri, Associate Professor at the Department of Aeronautical Engineering with Institute of Aeronautical Engineering College, Hyderabad. This course is intended for aerospace and aeronautical engineering students. Over the lectures, the objective of this course is to educate you with various gas turbine engines and major components of gas turbine engines, their functions, and different types of gas turbine engine components like inlets, compressor, combustion chamber, and nozzle, turbines and nozzles. And this course will introduce you the design parameters and performance characteristics of these components. Before going to the course details, let us think about one moment. Let us think about how do an airplane fly. Aircraft needs two things to fly. One is thrust and other is lift. Aircraft engines are designed to provide or to produce thrust, which makes an aircraft to fly at which makes an aircraft to move at high speeds. That is the purpose of aircraft engine. While the aircraft is moving through the air at high speeds, the airflow over the wings creates lift force. The shape of the wing would be such that it creates upward lift force, which enables the aircraft to fly. Right? So, aircraft engine produces necessary thrust to move the aircraft at high speeds, and wings are designed in such a way that which will produce lift, which enables the aircraft to fly. Right? Here we can see from the engine, air goes back and plane goes forward. While the plane is moving forward, the flow over the wings generates generate lift, and thus the aircraft flies. These are the four types of forces acting on aircraft. Two are natural, that is weight of the aircraft, and drag, that is a resistance by atmosphere to any moving body. Right? Weight and drag. And two artificial forces are provided, and which makes the aircraft fly. That is thrust. Thrust is supported by aircraft engine, and lift is by the shape of the aerodynamic shape of the wings. Right? The aerospace propulsion, this course, aerospace propulsion system is a machine that produces thrust. The contents of the course are as follows: classification of gas turbines and inlets. That is like components of gas turbine engines. There are inlets, compressors, combustion chambers, and turbines. And there are different types, and design parameters and performance characteristics would be discussed through this lecture series. And also different types of nozzles and their operating principle and design parameters. If you consider internal combustion piston engine, these are the four processes of one cycle. that is intake, compression, combustion, exhaust. All this process would take place in one place, that is inside the piston, inside the piston cylinder. One after other only the process can take place here, right? All these four process intake, compression, combustion and exhaust will take place only in one place, and each process will occupy this chamber one after another. At a time they cannot occupy this chamber. Whereas gas turbine engine, all the components are given separate place, and all process of cycle can simultaneously can work, which means continuously they can work. In previous case, one after another only, after intake, then compression, then combustion. But here, intake, compression, combustion, and exhaust, everything can take place simultaneously. Right? These are the major components of gas turbine engines. First one is inlet and compressor. This is a compression section. Then combustion chambers, then turbine and exhaust section. Right? Inlet, compressor, combustion chamber, turbine and exhaust section. These are the major components of gas turbine engine. We will see one by one what are the preliminary function of individual components. We will see. Inlets. All turbine engines have an inlet to bring free stream air into the engine with less energy loss. These losses may be due to ram effect or drag. So inlet should have proper design such that it directs the flow of air into compressor with minimum losses. We can see here the picture of subsonic inlet, and the inlet sits upstream of the compressor, and the inlet does no work on the flow. It just directs the flow into the compressor with minimum losses. Like it is, there should not be any turbulence in the flow while the flow is entering into the compressor. And proper inlet design and its performance, good performance, has a strong influence on engine net thrust. And different types of inlets we can see that those are subsonic inlets and supersonic inlets. And the next component is compressor. The primary function of the compressor is to supply sufficient air in sufficient quantity and at required pressures to the combustion chamber. This is a primary function of the compressor. Here we can see animation of a compressor. The compressor must increase the pressure of the air which is received from inlet and increase the pressure, then discharge it to the combustion chamber. Here the compressor composed of many rows of aerofoil shaped blades. In this animation we can observe here this row is rotating blades, and here you can see here next one, here also these blades are rotating, and these blades are rotating, these blades are rotating, while the other blades remain stationary. That is here. These blades are stationary and other set of blades are rotating. These rotating blades are called as rotors, and stationary blades in the compressor or of the compressor are called as stators. Right? This is a little introduction about the purpose of a function of compressor, and different types of compressors are axial compressor and centrifugal compressors. And the next major component of gas turbine engine are combustors or combustion chamber. The combustion chamber houses the combustion process, and the primary function of the combustion chamber is to raise the temperature of the air or extract the energy from the air and fuel mixture, burn it and extract the energy. That's what takes place in the combustion chamber. The combustion chamber houses the combustion process and which raises the temperature of the air passing through the engine, and it burns fuel air mixture and adds heat energy to the air, and then discharge the combustion exhaust to the turbine. Right? Combustion is a high temperature, one of the high temperature components of the gas turbine engine. You can notice here from this image, like from the compressor, air enters into the combustion chambers, and here fuel also will be injected through injectors, and air fuel mixture will take place here, and igniters will ignite the combustion, and combustion takes place. Then the products are discharged to the turbines, and this process releases energy contained in the air fuel mixture. And different types of combustors are can type and cannular type. The next major component of gas turbine engine is turbine, and here the exhaust of the combustion chamber would flow through the turbines, and they will rotate the turbine blades, and thus turbine generates or extracts part of the energy, and this energy would be used to run through the shaft, to run compressor as well as inlet sections. Right? The turbine transforms a portion of kinetic energy, that is velocity of the exhaust gases, into mechanical energy to drive the gas generator, that is gas generator compressor and other accessories. Here we can see the picture of turbines. These are turbines. The exhaust of the combustion chamber would flow through the turbines, and energy of the exhaust gases would be converted into the mechanical energy, and this mechanical energy through shaft, it would be transferred, or this mechanical energy would be used to run the compressor and other accessories of the gas turbine engine. And different types of turbines are axial flow turbines, radial flow turbines. And the last major component of gas turbine engine are nozzles. Nozzles converts the pressure energy available from turbine exhaust, or from turbine to kinetic energy. Here pressure would be converted to kinetic energy, which means nozzles accelerates the exhaust gases. Here other way we can say nozzle is the one component which produces thrust necessary to move aircraft at high speed. Right? Nozzle are the components which produces thrust. And picture of nozzle we can see, outer view of nozzle here. And nozzles provide thrust force required for all flight conditions, like during takeoff, during cruise, or any other loitering or landing, any maneuver. Nozzles produces required thrust. And other functions of the nozzles are thrust vectoring and thrust reversal. Thrust vectoring is like directing the thrust in particular or desired direction. This enables to achieve different maneuvers which are not possible in the regular way. Okay, maybe high climb rate, likewise. So thrust, another additional function of nozzle or thrust is thrust vector, and other one is thrust reversal. Like as the name says, it is a reverse thrust, means in opposite direction, which would help in braking, in slow down the aircraft. Right? These are the additional functions of nozzles: thrust vectoring, thrust reversal. And nozzles come in a variety of shapes and sizes depending on the mission of the aircraft. These are the major components of gas turbine engine, that is we have discussed inlets, compressor, combustion chamber, turbine, and nozzles. We have seen their primary functions also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.